in this video a circuit that was published in one of the Elector magazines in the 1970s, perhaps the 1980s, I don't know that exactly, but anyway, I made it and did some adaptations to get it better working. For instance, the original supply voltage was 12 volts. I have changed that to 18 volts up to 24 volts, etc., etc. It's an impulse generator, so you can ask, of course, what's the idea of a pulse generator? Well, it sends out pulses. You can see it here. Very, very sharp, in a certain way, needle pulses. And I will tell more about it, etc. At first, the schematic. It's here. They use a PNP transistor and a NPN transistor. For the PNP transistor I have used the BC557, and for the NPN I have used the BC547. Of course, say it's important that there must be enough current amplification regarding these two transistors, but that's in general absolutely no problem. And here are the pin connections, and here where I found it. And they told in the original document, the magazine of Elector, that when you want to get out positive pulses, you must connect the 820 ohm resistor in the emitter lead of transistor 2 and then take out at the emitter via a coupling capacitor or so positive pulses. Anyway, I didn't do that. I think this is more than enough to be showed. Again, it works better on 18 volts up to 24 volts. Here I've made a switch with which you can set, say, shortcut the 1K resistor that sets the bias of the second transistor, etc. Anyway, perhaps it's more interesting now to show how it all works. This is the circuit. The 1 mega ohm potentiometer that you now see in the middle of the screen is responsible for the frequency changes, and I've used a switch here, rotate switch, and well, with that switch I switch in different capacitors for CX, that's here. This is the NanoFarad, that's only an example. I found out that with 1 NanoFarad the frequency goes from 570 Hertz up to 6.8 KiloHertz. 10 NanoFarad 75 Hertz up to 900 Hertz. 220 nanofarad, 2 Hertz up to 35 Hertz. I'm gonna demonstrate that. Well, small overview of this circuit that works nice. That was my idea. Anyway, I want to refer to also the sound that the circuit makes. So now I'm working on 35 Hertz. These are the pulses. And now I tune the frequency potentiometer. Let's see what happens. So, quite lucky. And now I turn that 1 mega ohm potentiometer again to get to the higher frequencies. And with the capacitor of 220 nanofarad. It's always very, very irritating, that sound. Has everything to do with the pulse properties. Now I switch to the other capacitor. And that capacitor is 10 nanofarad. It's here. And we have now 74 Hertz. And the good thing of this circuit is that it has an enormous frequency band where it works. So you can generate pulses and also on a very broad frequency band. That's not completely clear now, but anyway, you see these pulses. 74 Hertz. Tune that 1 mega ohm potentiometer again. Let's see and listen. So we are now on 197 Hertz. It's completely normal, by the way. The pulses are perhaps not very clear to see because my scope doesn't want to trigger properly. Has perhaps something to do with the settings, etc. No problems. And again now to the highest frequency band. So perhaps it's you can hear it now because it's on 6.7 kilohertz, and here the waves, the pulses. That's the better idea, the best idea to tell. Well, you can surely see, and that was also originally in the electric schematic of the 1970s, that these pulses are very, very sharp and their duration is extremely tiny. But it doesn't mean that you can not hear them. So it's a very high tone. And now I turn that 1 amp potentiometer again. So again, I think it's a very properly working pulse generator. And with such a pulse generator you can drive, especially that's the idea, you can drive a transistor, say with a coil in its collector lead, etc, etc. There are many possibilities. And when you know something about electronics, you will surely know an application of this beautiful circuit of the 1970s or 1980s, published in the Electeur magazine. By closing this switch you can go to higher frequencies, and of course, not tested by the way, when you use a capacitor that is smaller than 1 nanofarad, say 500 PicoFarad, perhaps the frequency will also be much higher. I did not test that. I leave it as it is. Thanks for watching. Happy New Year 2023. 4. Well, perhaps it's interesting to show again what's happening in the circuit again. You will hear the sharp noise, and when you say switch this switch here, so that was only a demonstration, and again, thanks for watching.